Welcome to this new experiment for the synthesis of Indole. And today Nidhi is here, Nidhi Kumari, who will help us in doing the experiment and will show you how to prepare this phenylhydrazine and acetophenone, using phenylhydrazine and acetophenone, how to prepare the Indole. Okay, let's proceed. As instructed, we are going to do the synthesis of Indole today, and there are two-step process. First step is the preparation of hydrazone, and afterwards the rearrangement to make the Indole. For the first step, we need acetophenone and the phenylhydrazine, and we are now going to add the ethanol, which is the solvent here in this experiment. So 30 milliliter of ethanol we have taken. Now we are going to take the acetophenone inside the ethanol solution. The required amount is 1 gram. So now both are liquid, so it's got easily dissolved. So now we got the solution of acetophenone in ethanol. Now is a homogeneous mixture. So the second reactant is coming in, the phenylhydrazine, where the density is almost 1.1, so we need 0.9 grams. So it's coming around 0.8 milliliter of phenylhydrazine to the solution of acetophenone. Yes. So after adding these two solutions, all the liquids is nicely soluble, and we need some catalyst, which is the acetic acid, to promote this reaction. As per the instruction, we need only few drops of acetic acid, which will promote. In the mechanism already I have discussed this thing, so adding few drops, I think that's good enough, of acetic acid in the solution. Now you see we got a nice yellow color of the reaction mixture, but still no product yet. So for this we need to heat it up in the water bath. So we are going there for the heating. We have bought the reaction mixture here in the water bath and heating it. So for next 60 minutes we'll heat it up, and with some occasional stirring if required. If we see any solid, we'll stir it, and after 60 minutes we'll cool it down, and then we'll show you the product formation. 1 hour of heating, we cooled it down, okay, and you can see the volume we reduced a bit so that the precipitate can come. And I'll ask Nidhi to promote the this precipitation or crystallization by scratching. So you do it, Nidhi? Yes. Yes. You see here, sometimes this mechanical energy is useful to get the nice crystals, or just promote the precipitation, you can say. Yeah, this mechanical energy here in the scratches, from the scratches, this promotes the precipitation. You can see from these scratching points, more and more precipitates are coming. Yes. All right. Yes. So we'll continue this thing and allow all the products to precipitate out from the solution, and then we'll go for the filtration. So after the precipitation, we are doing as usual filtration, standard filtration, and as mentioned in the instruction, we are washing it with cold 2 normal HCl just to remove the unreacted hydrazines. So hydrazines will just get dissolved in the 2 normal HCl and then go away. Rest part, the hydrazone part, will remain as it is. Very nice precipitates of this hydrazone product. Definitely we'll check the melting point here, and also we'll take some part of it and proceed for the next step. We are proceeding for the second step. For that we have actually reduced the scale and taken 0.5 gram of the phenylhydrazone in a beaker, and now we are adding that phosphoric acid is here. Actually, you see the phosphoric acid is a very dense liquid. Okay, so you can't really drop it out. So we are, yeah, so it's just that's good enough, So we have taken just by a glass rod and then roughly taken 4.8 gram of it, because we are using a reduced scale, so that's why we don't need 9 gram. 4.8 gram we have taken here, and you see here. So I asked Nidhi to just make a star here, take it out from the balance. Yeah, give a starring here. Yeah, so you get a viscous kind of reaction mixture, you see here. But for this Fischer indole synthesis to rearrangement to takes place, we need heating. So we'll proceed towards the oil, this boiling water bath here, and place this one for heating for around 10 to 15 minutes, and then we'll show you the progress. Heating here, and you can see this viscous liquid now is turning into a transparent solution, and the color is also getting little bit darker, more darker. Okay. So we'll just continue for 10 to 15 minutes and then take it out and do the rest. We have taken it out from the reaction mixture. Now we need to add in the reaction mixture, we need to add the cold water. We're adding the cold water. Yeah, you can see here, oh, some precipitate is coming out. Add the whole amount of water, continue stirring. The precipitate, nice white precipitate of indole came out. You can see the color changed completely now, and this is milky white precipitate of indole, you can see. Okay, so it's getting settled down here. Yeah, you can see. Nidhi, start little bit. Yeah, you can see slowly, start slowly. Yeah, you can see the precipitate of the indole. We'll just wait for a few more minutes, and then as usual we will filter it, and then we'll do the TLC today. We'll show you how to characterize or differentiate whether the reaction is complete or not using TLC. Filtration here as usual. This milky white reaction mixture is giving very nice product, solid product after filtration. There's some fine particles there, that's why probably the filtration is a bit slow, but we'll just wait for a few more minutes so it sucks all the water. You can already see very nice product precipitate is coming out. Yes, it's almost getting dry. Product form is very white in color. Alright, so we'll just wait for a few more minutes so that all the water goes out from here, and then we'll perform going to do the thin layer chromatography or TLC. For that we need this TLC plate and the TLC chamber here with some solution here, you can see here, which will the eluent here. And as we have already explained separately, that we need to spot the reactant also. This is a solution of acetophenone, this is a solution of phenyl hydrazine. This is the final reaction mixture, the product where we expect to have the this indole product, and here is the phenyl hydrazine, the phenyl hydrazone, that the intermediate product of the first step. Okay, so these four solution we are going to spot here. So A is acetophenone, pH is the phenyl hydrazine, and P here is the product mixture where we expect the product, and this H is the intermediate step, that phenyl hydrazone, and C is the co-spot, which is the mixture of all these four. Okay, so we'll spot it here, and using this capillary here, this glass capillary, you can see, and this is some solution of ethyl acetate just to wash this glass capillary. All right, so I'll ask Nidhi to spot all these things here, and during the run I will show you again. You need to insert this glass capillary inside the solution, just touch it, and through the capillary action some amount of solution will come out, and then you need to spot that one in the required position here. Yeah, show it again, Nidhi. Yeah, in that spot. Yeah, you just touch it, so that little amount should go there. It should not be too much, it should not be too less. It's just the optimum amount that comes from the experience. Just for your knowledge, to put optimum amount so that the circle should not be too high amount. It should be a decent kind of 1 to 1.5 millimeter of circle solution. Yeah, we will continue this the same thing for the other solution as well. So now we will put the TLC plate to the TLC chamber carefully, and you see only little part of it will be inside the solution here. So up to here is there is a pencil mark, and we have made all the spots there, and the solution, the eluent should not this mark, pencil mark, should not go inside into the solution. Okay, so only through the capillary action solution should go up. You can see already this is moving up. All right, and once this solution is moving up, it's taking all these compounds, and depending on the polarity, some will move faster upward direction, some will move slower, and there should be some difference in these RF values. All right, so we'll continue this TLC until this solution goes up to a certain level, and then will take it out and then see with in the UV chamber. Run is complete. You take it out. Yeah, and then we'll see it in the UV chamber. Yeah, it's maybe too bright. Yeah, now the spots are visible. You can see here the first one, as I said, this is acetophenone spot. Second one is the phenyl hydrazine. This is our product spot. This fourth one is for the phenyl hydrazone, and this is the co-spot. Okay? So you can see already from here. So the color of the product is much more brighter than this acetophenone, although this acetophenone spot and the product spot, these are quite close to each other. The RF value difference is not much. The second spot, this phenyl hydrazine, is very polar because of the nitrogens, presence of the two nitrogen, and those are strongly binding with silica, so it's very polar. Acetophenone and the product is quite close. Okay, and this hydrazone spot here, it's got hydrolyzed in silica, that's why it's mainly showing the spot of acetophenone. The co-spot, but the co-spot you can see already, this is already two spots we can see. So in co-spot, what we have, the acetophenone we have as well as the product. So you can see like an 8 here. So that means there are, although those two are close, but there are two separate spots. Okay, and our product spot, you can see, is very nice round spot, and the product is formed. All right, so to have a better understanding or better separation, rather we'll run it again once more, and then again we'll show you the TLC. We have ran it for one more time. Now you can see the difference is little bit more here. So basically this is the product spot here. Okay, and I've just taken the TLC in a horizontal position so that you can see it better. This is the product spot, and this is the acetophenone.
This is the reactant acetophenone. Other reactant is here in the base. Now you can see, if you extrapolate, the position of the product is here, okay, and then I mean the RF value from the distance from here to here, and this is the acetophenone. So definitely the product is little bit more polar than the our reactant, but the difference is not too much, okay, but it's quite understandable. So these are the thing here from the TLC, from the lab. Now we took that product, it's quite pure, and we took it, and we have done the other spectroscopic analyses.